This problem actually contains a critical error. The crate should not be sliding down the inclined surface. It should be sliding up, because if the crate is sliding down with this initial speed, then the frictional force is not big enough to overcome the weight component. Therefore, the crate actually would never stop. However, after we have corrected that, now we acknowledge that the crate is sliding up with the initial speed of 10 meters per second, and we can actually solve this problem. So we need to determine the distance s the crate has moved when it momentarily stopped. So initially it's here. It has a speed of v1 equals to 10 meters per second, and then at the second stage v2 equals to 0. So we're going to solve this problem using the principle of work and energy. So T1, the initial kinetic energy, equals to or plus the total work done to this crate during this process from state 1 to state 2 equals to T2. And T1 equals to 1/2 mv1 squared, which equals to 1/2 times 50 times 10 squared, and that is 2,500 joule. And T2 is 0 because V2 is 0. This is when the crate has stopped. So the difference is the total work done to this object during this process. So we need to determine how many forces are doing work. So for that, we're going to draw a free body diagram. We can assume the crate to be a particle because we are not considering tipping over, so we do not have to do moment equilibrium analysis. So it's subjected to weight and a normal force. And because motion is in this direction, therefore the frictional force is always opposite to the direction of motion. The frictional force is here. So out of these three forces, so we have completed the free body diagram. Out of the three forces, the normal force is always perpendicular to the displacement. Therefore, only the frictional force and the weight force are doing work. And we can also determine that both of them are doing negative work because the displacement is in the opposite direction of the two forces. So now we're ready to write the total work done by weight during this process. It equals to its magnitude, which is 50 times 9.81 times the displacement. If this much is s, then the vertical displacement, the displacement up, this equals to s times sine 30 degrees. And we just said that the work is negative. And what about the work done by the frictional force? For that, we need to determine the frictional force. So we can summarize the direction. Let's say this is my x direction. So this is my y direction. We can summarize the resultant force along the x direction because there's no movement along the x direction. Therefore, the resultant force along the x direction should be 0, which equals to normal force minus w times cosine 30 degrees. So from there, and that equals to 0, equilibrium along the x direction. From there, we can solve for the normal force to be 50 times 9.81 times cosine 30 degrees, and that equals to 424.8 Newton. And because we have kinetic friction, the friction equals to kinetic coefficient times normal force, which is 0.515 times the normal force, and that equals to 63.72 Newton. So the work done by the frictional force also negative, and that equals to the magnitude of the frictional force multiplied by the displacement. The displacement is always along the same direction as the line of action of the frictional force, even though it's opposite direction. Therefore, the displacement is simply s. this negative sign indicates that the displacement and the force are opposite direction. Therefore, the frictional force is doing negative work. And now we are ready to write our equation for the principle of work and energy. So we have T1, which is 2500 joule. And then we have two negative work. The first one is 50 times 9.81 times S times sine 30 degree. The second one is negative 63.72 times S. And that equals to 0. So we have one equation with only one unknown. The unknown is S. This is a linear equation, shouldn't be too hard to solve. Therefore, from here we can solve for S to be 8.09 meter. And this is how much the crate would have moved before it stops.